Welcome to Machine Minds, where technology and humanity meet. I'm your host, Greg Terrusian, founder of Samson Rose, a recruiting and search business focused on the robotics and AI industries. The Machine Minds show is where we dive deep into the intricate world of robotics and artificial intelligence. As a staffing industry leader with a passion for the frontiers of technology, I'm pleased to be bringing you intimate conversations with the founders, investors, and trailblazers who are at the heart of the AI and robotics revolution. In each episode, we dig into their journeys, the applications of the products they're working on, and the breakthroughs that are shaping our future. Join us as we explore how these machine minds are transforming the way we live, work, and understand our world. Whether you're an entrepreneur, a tech enthusiast, or just curious about this amazing field, you'll learn something new with each episode. Let's delve into the extraordinary. Let's delve into Machine Minds. Hello and welcome to Machine Minds. I'm your host, Greg Terrusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, we are joined by Jeff Mahler, the co-founder and CTO of Ambi Robotics. They develop AI-powered robotic solutions for parcel sortation. Thanks for being here, Jeff.
Thank you for having me, Greg.
Let's jump into it. So as you know, I always like to pass it over to our guests to find out more about them. So can you start by sharing what initially sparked your interest in robotics and AI?
Absolutely. So as a teenager, I was fascinated with mathematics, physics, and psychology, as many nerdy high schoolers are. But I actually spent a good portion of my time doing manual labor. So I was a newsletter delivery boy walking around the Texas neighborhoods in 100-degree heat. I was a landscaper digging boulders out of the ground with pickaxes. And I also worked at a grocery store where I was a cashier, picking, scanning, and placing items as fast as I could. So I was always thinking about how to optimize performance in these kinds of tasks and imagining what it might be like for machines to work on these problems. And when I got to the University of Texas at Austin for college, I became really interested in programming and essentially getting machines to do these various types of tasks. I came to learn that computer vision was a huge missing piece of the puzzle at the time. So I found an opportunity to do vision research and worked with a professor and grad student exploring the use of new technologies like CUDA-capable GPUs and the Microsoft Kinect for 3D scanning of interior spaces. This eventually grew into my first startup, which was Lynx Labs, where we made a handheld camera to capture CAD models for architectural redesigns. And when we sold Lynx Labs to Occipital, a Bay Area-based company now called Canvas, I knew that the frontier was to build machines that could not only capture information passively, but interact with it. And I thought there was a huge opportunity to leverage this type of robotic technology to help people with manual tasks like I had always imagined back in the day.
Very cool. Very cool. So it sounded like it was that academic element that led into the entrepreneurial side. And obviously, Ambi isn't your first rodeo. So can you walk us through that academic journey leading up to your PhD? And what were some of those pivotal moments? I know you touched on it there already, but dive a little bit deeper into all of that.
Absolutely. So after Lynx Labs, I went on to UC Berkeley to do my PhD in Professor Ken Goldberg's lab. And Ken has been working on robotic grasping for his whole career, actually. In fact, since he was an undergrad in around 1980. So he has deep knowledge of this problem, and he initially gave me some starter projects to work on that. And to be honest, initially I was not that excited about it. Grasping is not necessarily considered a hallmark of intelligence for people. And so I wasn't really sure to what extent this was a hard problem. And there were also other professors around who actually didn't think it was the most exciting problem to work on either. So I was skeptical, but as I got deeper into the problem and tried to make robots actually pick up items, I realized how hard this actually was. And I became fascinated by that aspect of it. The fact that as humans, we sort of take it for granted. We can pick up a mug or a dish off our countertop without even thinking about it. But getting a robot to do that is tremendously hard, even when we have AIs that could already beat humans in chess for 20 years. So I got deeper and deeper into that problem. And at the same time, there were the beginnings of deep neural networks coming onto the scene. Around 2012 was the first ImageNet result. And so there was a lot of excitement in robotics about applying those technologies to robotics. And in robotic grasping, people were already starting to do that research to try to get robots to generalize to new items. At the time, robots could essentially only pick up items if you had an existing 3D model of them. So folks were doing things like labeling a lot of images by hand, basically putting grasp points into an image and training a neural network from that. Or they were having self-supervised setups where robots might collect data on their own for hours and hours, months and months, and eventually get to some baseline level of performance. And we saw an opportunity to actually make it easier to train robots in these types of environments, because labeling images by hand or having robots collect a lot of data, those are both very time consuming. And in the latter case of self-supervision, you need a whole army of robots essentially picking up various items, which is cost prohibitive and a huge engineering challenge. So we looked at how we could apply some of the older ideas from robotic grasping to maybe help with this data collection problem, essentially taking some of the models of analytical methods or simulations of whether or not a robot would pick an item up and apply those in an environment where we could generate a lot of synthetic data to train these AI models. So I started working with Stephen McKinley and David Gailey, who later became my co-founders on the mechanical side, to build a rig that would enable robots to be able to pick items up and associate the results of those grasp attempts with a simulation to try to figure out what sort of simulation actually worked best. And they went to the dumpsters of UC Berkeley and actually found an old test tube handling robot, revived that and set it up in the lab so we could start to collect data there. And we used a lot of 3D printing to associate items in the physical world with those in the virtual world. And through a lot of experimentation, we eventually identified a few models of contact physics that were good at predicting whether or not a robot would successfully pick up an item or not. So then we went to scale that up in simulation, and that became the DexNet or Dexterity Network project, which basically took a large library of CAD models, sampled them randomly, dropped them into bins or placed them in structured configurations, and then could run these analyses across the CAD models and associate grasping points with locations and images using techniques from video games, 3D rendering. And this turned out to be very successful. So we had a series of papers that showed that robots could learn from the synthetic data to pick up items with 2 fingers, as well as suction cups, and eventually led to us getting a lot of citations and attention elsewhere. So we got coverage in the MIT Tech Review, New York Times, and we even got invited to demonstrate our research system to Jeff Bezos himself at the Mars 2018 conference. So that was a pivotal moment, seeing his reaction to the system, trying to trick it with various items, even putting things like shoes and necklaces and avocados in the bin, and our robot being able to handle that. And seeing his reaction, we realized we had something that was truly state of the art there.
That's amazing. That's so cool. So it sounds like the traction started, I don't want to say early on, because there's obviously a lot of foundational work there, but before you moved into that commercial side of things, which is awesome. So transitioning from academia into entrepreneurship is obviously challenging, but moving from a research project into a commercial company, commercial solution is also challenging. How has that been, making those steps from the lab and Berkeley into, raising funding and then becoming a commercial company?
Yeah, that's a great question, and it's been quite the journey. So we initially founded Ambi essentially because we wanted to go beyond what we were doing in the research world, which was having cool demos and cool videos, but we really wanted this technology to help people, and ideally help people who didn't even care whether or not it was a robot, like truly provide value to some end user. And so we set out to do that. We initially thought that we might be able to do this via providing just software. So we worked with some of the industrial research sponsors we already had to provide our software for a few projects to run on some of their robots, essentially determining points where a robot could grasp. That turned out to have a lot of challenges, namely that there weren't a bunch of robots already out there in industry doing things in logistics like we originally thought. We thought there were all these arms already out there. If we add our software, they'll be doing all these things, but that didn't exist. And so that was one big pivot point for us, was to realize we need to build the full stack hardware, software, and even services around those robots in order to provide that value to the end customer. And so that took a lot of work to figure out what is the right system to build, how is it going to provide value to the end customer. And it involved a lot of customer conversations and just hard work. So we leveraged our network. We went to a lot of events. We did a lot of cold outreach, calling people, and leveraged LinkedIn heavily actually to reach out to folks, to ask them about their problems, interview them, build relationships, and see where we could help. And from there, it even took several years before we really had built a version of a system that was starting to provide that value to the end customer. I think we probably built between 5 to 10 different machine prototypes before we got there.
Wow, very cool. Was there a pivotal moment where you realized that this could be a viable business? Was it like that Jeff Bezos cosign, or was it from speaking to customers and potential partners where you were like, hey, there's no solution here and we have to build everything from scratch. This is what we need to do? Or was there anything else?
The Jeff Bezos moment was huge, but I think I didn't realize or have that moment of seeing a viable business until much later. And I would argue that a big pivotal moment for us was doing our first production unit of work with a robot. I still remember when we did our first package sort, we had been working on building this machine for about 6 months already, and we had been ideating on it with the customer for almost 12 months already. And we had a really grueling installation period, our first time installing this big of a machine in a warehouse environment where we took the whole company. It was 7 of us at the time, went down to the warehouse and just sort of lived there to work until we got it set up. And once we finally got that done, integrated with the customer software and gave it production packages, we first had one actually sort to the correct destination, and we confirmed it was where it belonged. I had this moment of clicking that we could really scale this, and one package could easily turn into 100, 1,000, 10,000, and now we sort well over 1 million a week.
Wow. That's amazing. And how long have you been in business for?
We've been in business for about 6 years now. We left the university a little over 5 years ago.
That seems like a pretty quick transition to, university project to 1 million packages a week. That's insane. Congratulations.
Thank you. It feels like a long time, but it's happened fast.
It's startup world, isn't it? 5 years in the startup world might as well be 25 in a large established company. So
yes, for
especially
sure.
the speed that you're moving. And I guess it's timing, right? Because there's a lot of things that have probably coincided with, like you said, when neural networks were coming on board, and then people adopting robotics to these kind of environments and things like that. It just had to line up for it to even become feasible. Because at a different time, when things might have been more expensive or people would have been more reluctant to even try something like this, those could have been roadblocks you wouldn't have even foreseen and would have stopped it.
Yes, and the pandemic was actually also interesting timing because essentially overnight, a huge amount of what was essentially brick and mortar retail went online. And so a lot of our customers were scrambling to move all these packages, and especially in the holiday season of 2020, nobody knew what to expect. There was surges of packages spilling off conveyors on the floor. And so there was a huge pain point there and a desire to help build capacity and uplift the workers that were there to help them handle more.
Yeah. Such a strange time, the pandemic, obviously. And the more people I speak to in automation space, robotics, it's that again was a pivotal moment where not only was the need glaringly obvious, but even since then, right, the lack of being able to staff these facilities, and then the need for consistency or 24/7 operation, and the willingness for those companies and those establishments to actually integrate new hardware, new technology, where it can solve the pain point, but before they might have been reluctant because people are like, well, I don't really want a robot. I don't know what I'm doing with that. Or why should I add more technology in this space?
Right. It felt like it went almost overnight from essentially a research project from these companies to a need to have, and people were considering it much more seriously.
Yeah, yeah. Let's talk about some of the challenges in AI and robotic manipulation, because it's obviously mentioned or often mentioned that manipulating the physical world is one of AI's greatest challenges. So can you explain why it's particularly difficult?
Sure, there are many reasons why. I'll talk about three. One is limitations in actuation and manipulators. One is limitations in sensing, and another is just the cost of data. So, on the topic of limitations of actuation, um, a big factor for the type of work we do is that robots don't have good hands. They often use in our work actually vacuum-based suction systems instead of something like a five-fingered hand, which people have. And there's various reasons for that. A big one is reliability. With suction cups, you can essentially just turn it on and off by flipping an air valve. And so it doesn't break down that easily. You may have to change cups, but it has very high reliability. Um, Versus five-fingered hands today, you can use some of them to work some of the time, but they break down a lot. But another thing there is actually the type of controls that go behind those types of systems. So with suction cups, we can do position-based control, which is very common today, and I would say in a fairly mature state across the industry. So we can essentially, if we can get a robot to touch a point on an item, we can turn on that vacuum and extract it. But with something like a five-fingered hand, you might have to do more complex controls. Uh, our hands have 26 degrees of freedom each, so that's a lot to control. And it's a big space of things, so it can be hard to do that very well. So that's one area where there's a lot of challenges. So we're essentially using simpler, more reliable manipulators that are easier to control, but they're more limited in what they can do. On the topic of sensing, cameras have come a long way, and especially 3D vision. We've seen all kinds of amazing work with things like vision language models, now models that can essentially get depth information from stereo pairs of images using AI, which is also super exciting to me. But vision isn't the only thing that's necessary to do manipulation of items really well. So people actually use a lot of tactile feedback in order to do this. And yes, it is possible to do these things based on vision alone, but it's actually much harder, I believe, to do it without things like tactile sensing, having really good force feedback, even things like sensing temperature. These
Mm,
things sort of don't exist. And I tend to think of robots as just being numb today. For the most part, they are.
yeah.
It's not true across the board. But try to imagine what it'd be like to, go through your home and do your laundry and, put things in the dishwasher if you were completely numb across your entire body. You'd probably break a few things. Um, and lastly, on the topic of data, so a lot of the great AI results we've seen over the past several years are leveraging things like internet scale data to train, say, ChatGPT on trillions and trillions of tokens found across the web that have been curated. We don't have that kind of data for robotic learning. And it's possible that we need actually quite a bit more data to achieve similar kinds of results because we're dealing with sensory data that has many more bits of information. And if we include things like tactile, that even explodes that much further. So we still have a long way to go in terms of collecting data. Um, I'm a believer that by commercializing these technologies, we will start to get that fountain of data coming in that we can leverage to build a data flywheel and make these models better over time. But it will take a long time, and I think it'll start with specific hardware um, instances of robots getting better at certain types of tasks, and we can start to build out more sets of tasks over time as we have more data.
Interesting. Very good points. Yeah, some of that I hadn't even thought about, especially the numb part of robots. I think, I've looked into a little bit, and there's obviously companies that focus purely on like haptics, right? But how does that, and this, you can educate me here because I don't know, but I know there's obviously the use case of like human in the loop, right? Where you put the gloves on or you put the VR headset and you're manipulating something else using that. How does a robot arm or any type of grasper use that, or can it?
So you can use VR to essentially translate your motions into motions for the robots. A lot of times that's based on the position of your hand as you're doing the manipulation in, say, this haptic translation mechanism.
Uh-huh.
But sometimes you can actually translate the full joint angles of a haptic device into the motions of the arm. That can be more reliable. But generally, we're sort of
So is that
controlling
is
the
that
position
robot
and
learning?
speed.
Is that robot learning from human, or is that just mimicking, or what would that be classified as?
Robots can learn from humans in this
Yeah.
environment. Mimicking is a good word for it. We typically call this imitation learning,
That's
having a
right.
robot sort of mimic or imitate humans' actions and then try to generalize from those. And for certain types of tasks, you can generalize well, at least nearby the sort of setup in which you've trained the robot. But getting a broader generalization from that, I would say, is still an open problem.
Yeah. And then the feeling or sensing of it, is that just a whole other ball game in terms of like the sensors?
I would say so. There's haptic feedback devices,
Yeah.
and a lot of cool developments there have actually come from surgical robotics, where they're trying to
Mm.
provide that feedback to surgeons because these teleoperated robots are actually used quite significantly in surgical environments today. But it's not widespread. It's not something that people are easily able to use. And there's, I think, a few reasons for that. One that comes up in our line of work with industrial robots is we don't always have good mechanisms to even translate forces the robot's feeling into haptic feedback for such a
Yeah.
device in the first place. And yes, there are some technologies that exist. They tend to be either sort of cost prohibitive and or limited in what they can sense. So something like robot skin, there are some starting points there, but I would say it's not anywhere near what we think human tactile capabilities are in terms of how fine resolution we can pick up when we touch things. So
Right.
I do think there's a long-term opportunity there to really improve robotic manipulation through tactile feedback.
Yeah, that's what I was kind of getting at, because it sounds like the only way to really get that is with a human in the loop. You know, you having the feedback glove on and feeling what the robot kind of feels, but it's still not going to be 100% accurate, right? Because it may have a lot more strength or less strength than you do to lift up an egg or a glass or whatever package it is, and it can just easily slip out. So yeah, interesting. Um, so Ambi Robotics, you guys specialize in simplifying robotic systems specifically for logistics. What are some of the unique challenges that you face in the industry, that you say, and you kind of separate yourself as well from other competitors or people in the space?
Yes, so in logistics, there's a number of unique challenges. One is that it's a very dynamic environment. So in logistics, the types of packages that we're handling are changing all the time. I used to think of parcels as being essentially just boxes, but there's actually a
Mm-hmm.
lot of bags. Bags have a lot of interesting ways they can fold, and people print a lot of different logos and marketing material on them, so their appearance changes all the time. And this sort of dynamic aspect of the items to be handled is one of the challenges. Um, but there's also the operational challenges. So it is an industrial automation task. We have to be very good at our KPIs like throughput, sort accuracy, the uptime of the systems. There's a lot of challenges in terms of making robots fit into a very tight floor space because a lot of the opportunity is in augmenting warehouses that exist today, at least currently, and the floor space there can be very limited. You have to fit a robot in a very small space. And so we're always kind of trading off these various variables in order to build a robotic system for these tasks. Some of the other challenges come on the more business side. So shipping is a margin-based industry. People are choosing shippers based on, saving 1 cent a package, that kind of thing, even fractions of a cent. So we have to make things very low cost. And it's a conservative industry too, because companies live and die by their ability to ship packages during the holiday season. That's what we all want, is to get our packages for the holidays. And so being able to be that reliable is something that you really have to prove before customers are going to adopt your product. And so that translates into a long sales cycle of getting robots adopted, excuse me. But over time, um, as you build more trust with these customers, you can start to grow and scale with the ones where you've built that relationship.
Yeah, yeah, I bet. I guess the adoption is one thing, but then there's also the reliance, right? Now, do we trust it enough and rely on it enough to remove a team member or let this thing run 24/7 or when no one's there or anything like that? That's probably a whole other hurdle to overcome before they're 100% satisfied or comfortable.
Yes.
Yeah. So you mentioned earlier on the importance of or the work that you guys did on in your simulation environment at the early stages. Is that something that you still focus on, or the learning from that, does that help overcome any challenges with what you mentioned just now?
Yes, absolutely. So for the handling the dynamic environment, the simulation to reality learning is still used. We start by building a digital twin of any machine that we're going to put into production, and we can run many virtual packages or other items through it so that we collect data, train an initial AI model, and that tends to be the basis for the first version that ever goes into the field is running some model that's usually trained either entirely or mostly on simulated data. So that enables us to have a working system on day one that can handle this kind of dynamic environment, which is really important. And then as we collect more and more data from the real production, we can train on a higher percentage of real data and continue to improve performance over time. Another area where we've taken a lot of learnings from research is on the hardware side. So all of our systems are very modular and built off of various components. We try to use off-the-shelf components when we can, like robot arms, cameras, even traditional automation equipment like conveyance. We've also developed a lot on the end effector, the suction cups, and how we can actuate those and integrate those with the controllabilities of the AI. So the AI can, for example, choose certain suction cups that are better suited for certain types of materials, for example, bags versus boxes, and more reliably pick up those items.
Nice. Nice. Let's shift gears here and talk a bit more about team building, corporate culture, all of those important things to running a company. You guys obviously have a great founding team, and you shared that story as well. And you've built a strong team at Ambi as well. What qualities do you really look for in people when you're hiring them, and how do you foster innovation and handle complex problems together? Because obviously, an innovative company and problem that you guys are working on.
For sure. And that's a great question. So we really think about making sure to hire people who are focused on helping the end customer. And one way I think about this is people who are interested in the why rather than the how. We all love AI here. We all love robotics, but we like hiring people who really focus on that end goal first and want to find the right solution for a problem. If we can solve something with hardware or maybe some traditional software engineering instead of AI, we will do that because we want to provide the customer the most value we possibly can. And some of the ways we look for the right people for our team is by testing our core values. Those are empathy, humility, being dynamic, dependable, and also curious. We think those things are all really important, and we interview people for that when they enter the organization. So that's something we care a lot about, is finding those right people who are very innovative, but also don't just want to do things one way, but really want to solve the end problem.
Love that. And it's always refreshing to me. Obviously, I'm in the hiring space as well, but I've been internal at companies and built and led talent acquisition teams, been part of HR, and been part of these, roundtables when you're thinking through your values and your culture and all of that stuff. And it ends up being just a piece of paper or something nice to frame and put on the wall. So it's always refreshing to hear when companies actually live and breathe their values and interview against them. And that's actually a data point when you are hiring someone, to make sure that they embody that, because it can be disruptive, if they don't, or if someone wants to be a Lone Ranger rock star. They might have a great pedigree and everything like that, but if they don't embody what you are looking for long term in your company, it's only going to end one way, right? And sometimes it can be the ripple effect of that can be more destructive than just that individual. It can cause attrition, it can cause project issues, innovation issues, deadlines being missed, things like that.
Yeah, I 100% agree with that. And we have a dedicated culture fit hiring panel actually to
Oh, really?
focus on this for that reason. Yes.
Can you talk more about that? How does that work? If you don't mind sharing.
Yeah, so what we'll do is we'll bring in a panel of 3 people and we'll choose those people from departments outside of the department that this individual is going to be hired in. And then we have essentially a database of questions that are designed to test each of our core values. They're usually asking folks to give an example of how they maybe handled a particular situation in the past. They try to focus on past examples and sort of like instead of how you would solve doing something, just like how did you actually do this? And sometimes the questions can be more provocative, like give an example of a time where you made a big mistake or a time where you disagreed with your manager. These types of things are what we're sort of looking for. And so we want that data point of other people in the org who believe this person fits with our core values whenever we make a hiring decision.
Love that. Love that. I will put a caveat in here for any early stage founders. How big are you guys now? How many employees?
We're 50.
50. So at the very early stage, it can be detrimental. And I've seen this where people forget or don't look at like there's culture fit, but then there's culture add. And when you're very, very early stage, for example, you and your co-founders in the same university or lab and everything like that, sometimes I've seen people that just want to hire themselves again and replicate that instead of adding to a culture and growing and having diversity of thought and background and input. And then what's also important here is you're bringing people from different departments in, which is key. Even though that person might not be, maybe they'll work with them collaboratively or cross-functionally, but they're not reporting to them or directly in there. I think that's so important because sometimes you just end up having a company of like-minded or just the same people. And sometimes that's a turnoff when people are trying to interview or come in there. And it can also hinder you from hiring exceptional people because you can't see past what you've created.
Yeah, those are some really good points right there. And I totally agree. You don't want to hire clones of yourself. The goal is to grow the culture that you have to, or at least I believe that. And so this is where it also becomes important to really think about what the core values are. We thought about that from the beginning, but we did refine it over time. And I don't think we got to the point where we could do this sort of interview that I mentioned until much later, I think probably 3 or 4 years into the journey. But those values are what we consider to be the principles of an individual that we wouldn't compromise on in hiring them to the org.
Yeah, definitely. I agree. How now, obviously you're commercial, you've got customers, you've got products out there, and you're, like you said, doing 1 million packages a week. How are you balancing these ambitious technical developments with practical business needs as well? I know you mentioned there about doing what's right for the customer and if it's just traditional software engineering instead of AI, etc. But that must be a tough balance, and thinking through or thinking forward instead of just what you need to do now. How do you maintain that?
It's definitely challenging, especially as we've grown. So one of the things we do is we try to expose everyone in the company as much as possible to the needs of the business org. One of the things we'll do every peak season is we'll have all the engineers who are working on the core machines actually go to the field and provide support. That way they're getting hands-on in the field, helping with problems, seeing how our customers are using the systems at least once a year. When we onboard new people, we will have them go to a customer site that's fairly nearby, so that way they can see how customers use the systems as they join the company. And then I think there are some other unique aspects that we do that help close that gap from sort of the end customer to the tech development. Our product and engineering organizations are very close. When we launch research projects, we will try to justify them with a business need and customer value. Think about questions like, how will this deliver value to the end customers? What is the opportunity for an increase in a KPI, for example, that the customer cares about? Is the opportunity to increase throughput by, say, 50 packages an hour? We want to define that in advance. And we'll also think about, how big of an impact can this have? Is this the kind of thing that might help one person in one specific case, or is this something that could be helping millions of people across the world? Those are the kinds of problems we want to be going after, and those things will drive which research projects we decide to take on.
Amazing. All right, cool. So there's still the research element as well as the product development side of things. That's very cool.
Yes.
Can you talk a bit about the business model? How do your customers actually utilize your robots? Do they actually purchase them? Do you have boots on the ground? Like you said, sometimes you send people out to support these robots. Does someone need to be trained on site to manage them? Do they own them? Is it a RaaS model? Like, all the different options?
Yeah, that's a great question. And I mentioned that one of the challenges earlier was sort of speed of adoption of customers. And we offer RaaS model, robots as a service, as one way to deal with that challenge. So customers typically do not purchase the system. They're paying for it on a monthly basis for some number of years commitment. Typically that's 4, but that can vary. And they're not just getting the hardware and the software that come with the robot. Obviously, those are very important, but they're also getting all the services around the robot in order to keep it running as well as possible. So we have support services. We have technicians from coast to coast in the US in different regions that can be on site within 24 hours if a problem comes up with the robots, that can log in the systems remotely and help deal with issues. We also have a spares program. That's a huge part of our business model. There's certain sort of consumable items on the robots, like suction cups. There's other things that will break down more frequently. And so we have a program whereby customers, as they're using various spares, it'll update our database so we know when they need more spares and can send them preemptively, make sure they're not going to have downtime from those types of goods not being there. And then another aspect of it is them having access to our platform where they can access various elements of the production performance, like analytics. So they can log in, see how their systems are performing, monitor for robots that aren't performing as well as they should be, and help optimize their network based on all the data the robot's collecting.
Nice. Typically, how many, and you don't have to share this if you don't want to, and I'm sure it varies with the size of your customers, but how many do they normally bring on? How many robots does a typical customer normally bring on? And second part to that question, do you normally see them say, hey, let's try one, and then it's successful and they're like, all right, let's bring in 4 more?
Yes, it's much more like that. So customers will usually start with 1 or 2, and then start to roll out to additional locations in the existing facility or additional facilities from there. So it usually looks like roughly like a 110, 100 kind of scaling model. That can vary based on the customers, but they usually want to get comfortable with 1 or 2 robots before they start to scale.
That's cool. All right, thanks for sharing. All right, let's talk about the future. What's next for Ambi Robotics? Anything big happening in the near future that you can share?
Lots of big things are happening. We are hyper-focused on growing our deployment base of our existing products, particularly the Ambi Sort A series, which is sorting parcels to mail sacks for last mile deliveries. A lot of our focus is on improving that service, improving the performance of that product, and there's a lot of activity going well. We're also working on launching some new machines that can serve new types of applications with even bigger markets, and bringing in some new technology advancements that can help robots do some tasks that they may not have been able to do before, ones that involve things like sequential learning, understanding the sequence of how they might pick up items or place them. We're very interested in those kinds of advancements, and we have some new machines on the way that will leverage that to solve some even bigger problems.
That's exciting. Wow. Okay. I will definitely be keeping a lookout for that. In your view, what will the impact of AI and robotics be or look like for everyday life in the next decade? outside of just logistics. I mean, obviously we don't see that as a consumer. We just know, hey, our package arrived. It's great. We don't know how it got sorted, but for everyday life, for people that are aware, what do you think that would look like?
Yes, I love this question. It's always very hard. I will say, I think that how the world will look different. Well, on one hand, robots are starting to make an impact in industrial automation in a bigger way. And to your point that maybe the end customer doesn't see that, they will see aspects of that, like the ability to get packages faster and cheaper to your front door, the availability of various products, perhaps at a lower price, perhaps more customized. If you want to make something personalized to you, those things can start to become easier. You may not notice that those are robots. Some of the areas where I think you'll start to see more robots around you are places where there's a lot of repetitive service work. So robots are starting to be deployed in places like restaurants, storefronts, hospitals, even nursing homes, and places like parks. We talked about my friend Electric Sheep earlier, Mike Lasky, and I think there's going to be robots doing things like that as well, mowing parks. So I think you'll start to see robot assistants in those types of places. And worth mentioning, I think that there'll be more of this in the cars we drive as well. It seemed like inevitability for a long time, but driver assistance is starting to become so good that I think we'll be starting to just use that on the highway at all times, and maybe some other places as well. And something that almost seems like there was so much hype that we discounted it, but I think in a decade that will be coming to fruition in a bigger way too.
Yeah, yeah. I think it's a very good point, and people forget that it is a type of robotics, right? And it's definitely AI, and it had such a big hype and such a big bubble and so many eyes on it. We've heard all the horror stories and companies shutting down and stuff like that, but the technology is still being developed. And, I was at CES in January seeing some of the technology being demoed and displayed, and some other companies that are so cool that are just making that element to embed into robots and into cars. And it's coming a lot quicker than we think. It's just more, I think, the regulation side now and who's going to adopt it and be okay with it. But it's definitely there. That's why I'm so excited about
Yes.
off-road as well. Because you
Yes.
can get level 4, level 5 autonomy a lot easier than you can on the open road.
Right.
From a regulation standpoint, anyway. Okay, cool. So is there anything else that you're particularly excited about or even maybe concerned about that's coming, emerging technologies?
Yeah, that's a great question as well. So it's hard not to be excited about the progress in generative AI. Vision language models are super interesting, and I think we're just starting to explore the impact of those types of models in robotics, handling more open-ended tasks. I'm seeing a lot of interesting progress on researching robots in the home. That seems pretty promising. I'm particularly interested in how this type of technology can be applied, maybe in slightly different ways, to things like dexterous manipulation, where there's been a lot of advancements in hardware. Humanoids are one element of that. One thing coming along with the humanoids is actually more development of multi-fingered hands, which I'm super excited about as somebody who works in grasping and robot manipulation. So that's something I like to pay attention to. And I'll say it again, I mentioned earlier, tactile sensing. There's been a lot of exciting work there, and I think that will continue. And that's one area that I think will be really, really big as the hardware starts to mature. And then the software techniques that come along with that to leverage that data will be really fascinating for dexterous manipulation.
Very cool. That's great. Thanks for sharing. Okay, well, I know we're almost at time. Before we go, any advice or guidance or closing thoughts that you want to share with any entrepreneurs or people getting into the robotics space?
Sure. With getting into the robotic space, I think you'll find quickly that these things are very hard. Hardware is hard, and robots involve hardware. That's something to always keep in mind. But something I like to usually highlight is that as you're developing robots and trying to put them into the field with people, don't overlook that the operations around the robot start to become more important than what the robot can do itself. And that's actually a huge aspect of a robotics product that is often not talked about as much, but there are huge challenges there. How does the robot communicate that it needs help? How can you leverage somebody who has almost no or even no technical experience to help a robot fix itself, get it back running? These types of problems are extremely important, and anyone in robotics entrepreneurship is going to encounter those at some point. So it's an interesting area to consider for your own product, or even making your product entirely focused on those kind of things. I think that could be a bigger opportunity in the future.
Interesting. Great. And where can people follow you, follow Ambi, find out more about these new products coming out and any of your milestones?
Yes, so the best place to follow me is on LinkedIn. I'll post updates about how we're doing. Jeff Mahler, you should be able to find me there easily. And Ambi Robotics, we post a lot on LinkedIn as well. We're on Twitter, and you can find updates on our website as well, ambirobotics.com.
Perfect. Well, look, Jeff, I really appreciate you taking the time to be on the show and sharing everything with us. Thank you. And I look forward to following you guys, your story, your journey, and all the progress you're going to make.
Yeah, thank you so much, Greg. It was a pleasure being on the podcast.
Thanks, Jeff.